All right. Welcome back, everyone. Ready to dive back into the wild world of higher maths. We all know those past papers can seem like a bit of a jungle, especially when it comes to straight line questions.
Absolutely. It can feel like you're wading through equations forever.
Exactly. But don't worry, we're here to be your guides.
That's right. We're going to break it all down today. By the way, great to be back with you all.
It's fantastic to have you, especially with your expertise. Now, you've all sent in your piles of past papers from 2015 to 2022, and let me tell you, the perpendicular and parallel lines section is looking particularly well thumbed.
A classic for a reason.
Right. And when I first saw this stack, I have to admit, it was a little overwhelming, but then I started noticing these patterns, almost like a hidden code.
Ooh, a code. Tell me more about this.
Well, it's the keywords. It's like they pop up again and again. Gradient, tangent, midpoint. Almost like the examiners are trying to give us clues.
They're not trying to be sneaky, though, right?
Exactly. It's more like they're saying, hey, these are the core concepts you really need to understand. Instead of memorizing a million different questions, if you crack the code of these key concepts,
You golden. You can solve just about anything they throw at you.
precisely. It's about mastering the underlying principles, like how to work with gradients or manipulate those equations of lines.
And then those tricky perpendicular and parallel lines. They won't stand a chance.
Okay, so we've cracked the code, we've got our key concepts. Time to put them into practice. I've got some of those well-thumbed exam questions right here, ready to tackle them.
Hit me with your best shot. Let's see what we've got.
All right, let's jump right into the 2015 paper, question 9. This one's all about finding the equation of a line that's perpendicular to a given line.
Ah, a classic perpendicular line problem. Always a good time.
Right. So they give us the equation of the first line, y equals 2 by 5, and tell us it passes through the point 3, 1. Feels a bit like a mathematical puzzle, doesn't it?
It absolutely is. And just like any good puzzle, we need to find the missing pieces.
Exactly. So where do we even begin with this one?
Well, we know the name of the game is perpendicular lines, right? So what's the first thing that pops into your head when you think about perpendicular lines and their gradients?
Perpendicular lines, gradients. Oh, they multiply to give us -1. That -1 is crucial.
You got it. That's the key that unlocks this whole puzzle. So we know the gradient of our original line is 2. What do we need to multiply that by to get missing 1?
Let me see, 2 times. Missing a half. That's our missing gradient.
Perfect. See, you're a natural at this. We've got our gradient and we have a point, 3, 1. That's all we need to build the equation of our line. Remember our trusty y equals mxc?
Of course, m is the gradient and c is the y-intercept.
You've got it. Now we just plug in our values and solve for c.
And that'll give us the equation of our perpendicular line.
Yeah.
No, I'm already feeling more confident.
Yeah.
But what about something a little trickier?
Bring it on!
Perfect. Let's look at the 2019 paper, question 7. This one involves gradients, tangents. It even throws in some trigonometry for good measure.
Ooh, mixing it up. I like it. Those tan functions can seem intimidating, but remember, they're just another way of expressing gradients, especially when we're dealing with angles.
Right, angles, slopes, it's all connected. So this question gives us a curve and asks for the equation of the tangent to that curve at a particular point.
Okay, and what's the key connection between a curve and its tangent at a given point? What do they share?
They share. Oh, they share the same gradient at that point, of course.
You're on fire today. So how do we find the gradient of the tangent?
Well, we need the derivative of the curve at that specific point. Then we can just plug in the x-coordinate of our point into the derivative, and boom, we have our gradient.
Exactly. And once you have the gradient, you're back in familiar territory using y mx best c to find the equation of our tangent line.
It's amazing how, even though the questions look different, they all come back to those core concepts. Gradients, equations, a little bit of trigonometry. It all fits together.
It's like building with mathematical Lego. You've got your bricks, the
Right.
core concepts, and you can use them to build all sorts of amazing things.
I like that. But there was one example I wanted to touch on. It wasn't tied to a specific year, but it was in my notes alongside the others. Something about medians and altitudes of triangles. Should we
Yes.
be worried about triangles showing up on our straight line exam?
That's a great question, and it highlights something really important about these exams. It's like this, they could throw just about anything at you, right? But the real trick is they're not just testing if you can remember a formula.
Right. It's not enough to just memorize it.
Exactly. Anyone can memorize a formula, but the real test is, can you apply it?
Can you use it in different situations and contexts? Right?
Yes. It's like knowing the ingredients for a cake doesn't make you a baker.
Okay, I like where you're going with this.
Right. You need to know how those ingredients work together, when to adjust things, how to tell if it's all gone wrong.
It's about understanding the why behind the what, not just the what itself.
Yes. And that's where showing your work becomes so important in these exams.
Because it's like giving the examiner a peek inside your brain.
Exactly. They can see your thought process. So even if you make a tiny miscalculation, they can see, okay, they get it.
Right, like they're thinking about this in the right way, even if their final answer isn't quite there.
Precisely. And the other thing I often see tripping students up is that deer in the headlights moment when they see something that looks totally new.
Oh, I know that feeling. Like, whoa, I've never even seen a question like this before. Where do I even start?
Yes. And it's so easy to freeze up in that moment. But here's the thing. Examiners, they love to weave different topics together.
Right, it's all connected.
Exactly. So even if a question seems totally out of left field, take a breath, look for those familiar building blocks.
Look for those core concepts, the stuff we've been breaking down today.
Because often you'll find that a question that looks totally new is actually just those familiar ideas dressed up in a new outfit.
It's like those parallel lines we were talking about earlier sometimes. They look totally different, but underneath it all, they've got the same basic structure.
Yes, it's all about finding those connections, those aha moments where suddenly everything clicks into place.
And that's such a good feeling when it happens.
The best. So next time you're facing down one of those beastly higher maths questions, just remember, it's not about memorizing every single variation. It's about mastering those core concepts.
It's about having the tools and knowing how to use them to build whatever you need, even if you've never seen the blueprint before.
Perfectly said.
And on that note, we'll leave you with this final thought. Could you use what we've learned about straight lines in 2 dimensions to solve problems in 3 dimensions?
Ooh, now there's a challenge.
We'll see you next time for more mathematical adventures.
Happy studying, everyone.